Okay, so we're live now. Okay, then. Hello, everybody. Welcome to the first single executable team meeting for 5th September 2022. And this is the first project kickoff call, so we'll be just walking through the discussions and issues and PRs and all the activity that has been happening all these days. So yeah. And since we're all new to this meeting, to this team, actually, let's all start with some introductions. So I'll go in ascending order according to everyone who I can see in here. So let's start with Anna.
Hi, I'm Anna, former Node.js TLC, and currently at MongoDB, where we maintain a single executable application package for Node.js. Okay. And that's why I'm here.
Yeah, that's very cool. Okay, Yusuf next.
Hi, I'm Yusuf. I want to get an idea what how the project is being and in which direction it's going. And I will primarily just hearing. Thank you.
Okay. And Tobias.
Hi all, I'm Tobias. I'm on the TSC and I'm really only aware of Anna's implementation, Box Node, I believe. So I don't know much about the ongoing discussion.
Okay, then I'll go last. So, hi everyone, I'm Darshan Sen from the TSC and I work at Postman. And we're also really looking forward to single executable support in Node so that we could build the Postman CLI. It's still a work in progress, so yeah. So that's that. So let's start by going through some of the issues and discussions in the repo. So the first thing, okay, I'll start by sharing the screen if that's good with everybody. Okay, so the first thing that we did is we added a blog which tries to go through everything that has been done for the single executable implementation in various projects. So we have things like Box Node, PKG, and all of those other things. And we were just trying to document what the parts are for a single executable and what we can do to make it fully functional and have an implementation in Node. So in case y'all can go through this. It's pretty informative and yeah. And the other thing that we were trying to do is we opened a bunch of discussions here. So these are some really interesting questions. So we were trying to just discuss all of these things and let the idea of a single executable flesh out from these discussions. So the first thing that we really tried to document really well is the VFS. So when you have a single executable, it's just going to be one single file. And so the source code of your application, it would probably be bundled into the executable itself, probably in the form of a virtual file system. So we were really not sure if we should have just one virtual file system or should support anything that users just try to share the implementation of. So we tried to document all the requirements of a VFS here. So I sent the PR and this is what it looks like. So we have some points. So we have things that we do want to support strictly, and there's some other things that are not supported, and we have some optionally supported things as well. So y'all can go through this document. It's still in the PR stage, so you would need to go through it there. And we had some really interesting discussion about how we're going to deal with native add-ons in the virtual file system. So that seems to be one of the problems that hasn't been solved yet in the best possible way, I believe. Yeah, so this is the issue. So we have a couple of open questions there, like, what if we have a native add-on that relies on a path that's present on the file system? So what happens then if you package everything up into one executable? How is the native add-on going to read all of those things? So we really don't know the answer to these questions yet, but there are certain implementations in some other projects. Like we're also considering things like app images, which is not really a single executable in the context of Node.js projects, but it's a thing, and it's pretty similar to how single executables work. So the only problem is that it's not really implemented on all our supported operating systems, so we don't really know how we can use this. And there are also some other things like the Fuse file system and all of that, but then again, I don't think there is support for all platforms that we support in Node. And also there are things like, what happens when you start the application? Like, should we unpack the VFS onto the file system? So should we do it all the time the application is started, or should we only sometimes? So we're really not sure about that. So I would really appreciate it if y'all can do some review work on this document. So I'm trying to document every single requirement over here. So I think we can go through each of these points together in this call. Does that sound good to y'all?
Sure.
Okay, cool. So one of the primary supported items is random access reads. So we do want this file system to be something like where you're able to access each of the file contents in a random access manner. So you wouldn't have to parse the entire file every single time to get a hold of the contents of a specific file there. So it should hopefully be an order of one operation. So that's something. And I don't think this would be hard to implement. Like, this is probably what's done in most file systems that are used for single executable stuff in the Node ecosystem. So that's one thing. And the next thing is symbolic links. So this is a very interesting topic. So I was trying to play around with the SAR format from Electron, and they actually don't support symlinks. So when you have things like Dugite as a dependency, so Dugite is a Node project, and it actually contains Git LFS executables in it. So you're actually able to package the Git binaries into your application. But the problem here is that it has a lot of symlinks, and when you try to build an ASAR out of it, it would resolve each and every symlink, and the package size would go up tremendously. So that's not something we want in our virtual file system. So we do need to support symbolic links. So that's one thing. And the next thing is about preserving the executable bits of the file permissions. So we could probably support all the file permission bits, but I guess it's only the executable bit that showed up for our use cases. So I'm not sure if you guys have any other thoughts here. Does this look good, or should we also support some other file permissions? Okay, I guess there's no objection to what you're suggesting here. So you go on to the next topic. So this is about optional data compression. So when you try to read a specific file from the VFS, it might be required to compress it, because sometimes if your project is huge, it probably won't even fit into the maximum file size if you compress it and just inject it into your binary. So in some cases, it might be required to compress this, but the only downside is that to read the contents again, you would need to decompress it and just use the data after that. So that's kind of time consuming. So I guess we need to support this optionally. So it's totally up to the user if they want to compress it and so on. So I'm not really sure if you all are aware of certain file systems that support this optionally. So in case you'll know about it, feel free to let me know right now.
I will say that this feels like a secondary concern, something that would probably not have to be part of initial MVP for this.
Okay.
Like, I get that this is nice, but if we have a VFS implementation to begin with, then people could probably gzip their whatever they want to have compressed and put that in the VFS, and then, load the compressed file and decompress it in the application again. Like, there are ways around this without having to build this into a solution.
Okay, so do you mean that the users would have to compress it or just keep it uncompressed before it's packaged into the binary?
Right. What I'm saying is we can offload this concern onto users. And it might be nice to have this in the solution itself, but I would not make this like a requirement for the initial implementation.
Okay, interesting. So in case we let users handle this completely, I guess the VFS is supposed to just know which files are compressed and which require decompression and all of that. So I'm not sure if there is a way to just keep that data into the VFS. So the application can load it by compressing it, or rather decompressing it.
Right, that the application would decompress it. I think that's perfectly fine.
Okay, so we should keep it in a decompressed state in the MVP.
That's what I would recommend, not to worry about compression at all in the MVP.
Okay, yeah, that sounds good. Okay, we have some more people. Let's promote them. Hey Juan, hey Mao.
Hey. Hello. How are you guys doing?
Yeah, I'm doing good. Would you all like to give a short introduction of who you all are and what your interests are in this project?
So my name is Mael. I've been working on JS tools for both Node and browser, and I maintain Yarn. Since we are implementing VFS, I'm interested in progress in this area.
Okay, nice. And what about you, Juan?
Hello, everybody. I am the lead of the desktop engineering team at Postman, and we're very interested in just bringing SCAs into an actual thing, as we're actually going to be releasing a proprietary Postman CLI soon, and we have been encountering a lot of problems in this area. So yes, it's going to be very fun to actually solve them, right?
Yeah, absolutely. So just some context for you all. So we've been going through the requirements we were documenting for the VFS. So we're at the optional data compression thing here. So Anna raised an excellent point here. So it might not be the great thing to do if we handle the data compression part in the initial MVP. So yeah.
Can you summarize, by the way, because I joined late, so I might have missed most of the points. Can we do like a 1 minute summary?
Yeah, absolutely. So I went through all the discussions that were happening here. So I talked about the blog post that we wrote in here. And then we were talking about all the discussions that were opened. Like, these are some really interesting questions, and we might not have the answer to all of these at this point. So yeah, we're trying to attend to all of these. And then we were talking about all the points that we wrote in here for the VFS requirements, which is still in the PR state. So,
so I think, in the interest of focusing on the requirements, which I think is like probably the best use of the time, right?
yeah.
So can you summarize like any of like the main interesting points on the VFS requirements?
Sure. So the point that I find to be super interesting is regarding native add-ons. So I'm really not sure how we're supposed to support that in the VFS and what downsides we should also support, because I guess there's probably no way to implement this perfectly at this point, because there's no support for all operating systems. So yeah, like one of the main questions I had was about when you have a native add-on and you embed that into the application. The first question is, how do you load that? And whether you should decompress it on the file system and then just load it as a shared object, or should we do it from memory? So that's something that
I don't know if people in this call have like any insights, but I think one of the things I was mentioning in there that I think would be very interesting to try out is that the only project that, to the best of my knowledge, has managed to solve this problem very elegantly, these app images on Linux, right? And I don't think that there is any way to like just port over the concept of app image to other operating systems out of the box, but it seems like, what they did, like the essence of what they did, actually solves all these problems. And I wonder if there's any way that we're like ignoring, that we could make essentially, how would you make app images cross-platform, right? And if you make that happen, I mean, not app images themselves, right? But the model in which they like mount the app image on the fly at runtime, right? And then unmount it, because if something like that could be implemented cross-platform, then that would solve all the problems, right?
Yeah, true. I wonder how app images try to solve this problem. Like, do they place the native add-ons or like every single file on the file system, or do they?
Yeah, so the idea it is a proper file system, right? That they mount using Fuse. And the thing is, by using Fuse, for example, to the best of my knowledge, because they mount I think it's essentially like an ISO format, right? They mount it on the fly. It doesn't occupy extra space on the operating system, right? It's just a view over the same ISO file. And because it's managed by Fuse, then you can mount it, very nicely. You can make it only readable to you as the user that has mounted the Fuse. And then Fuse has this interesting option that whenever you stop executing the main like process within that thing, it's guaranteed to like unmount the app image and not leave any trail behind. And it all happens transparently by Fuse, which is pretty cool.
Okay, interesting. So what happens when you try to launch multiple applications from the same binary, rather multiple processes from the same binary?
So you mean executing the app multiple times?
Yes, in parallel.
Yeah, so the mount point is like a semi-random generated, I think, mount point or something like that.
Okay, interesting. And I guess these don't interfere with the other processes.
Yeah, correct.
Totally
so you can,
okay.
So you can run them like multiple times. Even multiple users could execute the same app image at the same time on the same system, and it's guaranteed, I think, to work. But the thing is that app images, they rely on a lot of like very Linux specific stuff, right? So then my question is like, is there any way that we could port some of these concepts over? And I'm not like, I don't know if it's possible or not. I really have no idea outside Linux for app images, but I was wondering if anybody in this call has any insights.
It's been a few years since I wrote a Fuse driver, but at the time I tried to port it to Windows and it didn't work at all. There's like file system filter drivers on Windows, but as far as I remember, you cannot use them without administrative privileges, which is not the same for Fuse, I believe. So it would be much more difficult to support cross-platform.
Yeah, indeed. And I wonder if there is something like Fuse, even if it's not Fuse, that you could use, right?
Yeah. I was also wondering about the startup time. Like, does this create the mount point every single time you run the executable?
It is, but I think in app images it's very fast. But I don't know if it's because an implementation detail of app images or just Fuse being like very fast on Linux. But I think you can try it out if you, I mean, you have a Linux system, so you can probably download a couple of app images and like run them, even some of the examples. But as far as I remember, the startup time is like very fast.
But that's only for Linux, and there are 2 other systems where Fuse is not really portable, and even if there is, we have no control of the performance on startups. For instance, we can't guarantee that on macOS there won't be a change that will make Fuse very slow, or same thing for Windows.
Yeah, indeed. But the thing is that, you know, like the core of the issue is that you either decompress or mount, you know, the single executable application or in one shot into like a real file system. And then you can do, for example, native add-ons very well and a lot of the other things that we have talked about, right? Or we only read from within the BFS, right? Which reduces the complexity, but by definition, it will make some things like the native add-ons don't work.
There is another option, which is that the MVP can also not support native add-ons natively. And then it's user code that is tasked from putting those binaries on the file system and calling them.
So for the native add-ons, they can put it on the file system, right? For example, in you know at the side of the BFS, right? Something like what Electron does with the unpacked ASAR concept. But I think Darshan's main point is that if you have a native add-on, right, that uses C++ IO and tries to read back into a file that was then packaged into the BFS, then it's gonna have problems unless you actually unpack that one too. So then maybe that's an option.
Sure. Although aren't native add-ons generally self-contained and don't have dependencies on other things?
I mean, I think we don't have any metrics on that. I wonder if Anna knows, though.
I
how
think
common is that?
Mail is right. Yeah, it's 99% of the time. There's no explicit dependency on like files that are part of the package. There may be dependencies on like system libraries. If it's a binding for a system library, but I think that would probably not require any special VFS thinking.
Right.
Like that.
Okay, so then I guess to summarize, right, it seems like a good way forward, right, that kind of solves both things, is that if we support some sort of BFS where you can both embed files in the BFS, but also point to files outside of the BFS that are packaged, alongside the binary, like ASAR, right? I think ASAR is a perfect example of that with the unpacked thing that they have. You solve both problems. The only small asterisk that I can think about is that at that point you're not a single executable application, right? It's a packaged app in a way, but I wouldn't call it single executable. But I think that's fine.
It's not. And with native add-ons, it is a bit more tricky because a typical native add-on will include code to locate the actual binding, the actual add-on, the native code in JavaScript. And so this making it so that this still works with current add-ons is tricky in a VFS situation. Like the concern is not that the native add-on itself cannot access the file system. It's that the JavaScript bindings around it need to be able to find the add-on. And that might be tricky if the JavaScript bindings themselves are part of the VSS, but the native add-on is not. You know?
Right. And so one question for, yeah, go ahead.
No, a common solution for that is to also unpack the entire add-on package, including JavaScript and native add-on. That's what like Electron apps do, for example, in their app ASR unpack. But then you get into more and more trouble because this entire package, it might have other dependencies and node modules that you then also need to unpack and so on. So like it is worth thinking about better solutions here, I think.
Yeah, and also there is
tricky.
the problem about code signing, because if we unpack the JavaScript source files, we might not have a way to code sign this on Windows, so other applications could probably mutate those files, and that would be problematic.
Yeah, I mean, that's what I mentioned,
point,
that perhaps that's why I mentioned that perhaps we could let it, at least in the first iteration, to the userland code to decide whether they want to unpack some of the file that their own archive contain. Because if we have a VFS layer, then they could just use fs.cp to copy one file from their file system into the actual one and take responsibility of making sure that it's the right signature or this kind of thing.
But what then happens when the bindings for a native add-on try to find the bindings file and load it?
I'm not sure I follow.
Does something transparently copy out the add-on? Because it seems like you're suggesting not to do that.
I'm not sure I understand. Sorry.
So
I think the suggestion is that doing, I think what Mail is saying is that you leave that responsibility to the user for like the V1, right? It's like if you want to do that, you are responsible of copying that out, and no automatic thing is going to help you out. But that would be something for like V1, and then that would be something we revisit, if I understand correctly.
I mean, yeah, so it means that you have to copy the entire package out of the VFS, not just the add-on file itself, right? Just so we're on the same page.
I'm not very fluent with native add-ons. I have rarely used them. My understanding was that you could put them on the file system as a .node object, and then you could require them, and Node would load them transparently. Isn't that the case?
Yes, you call require with a path to a native add-on, but still that doesn't change the fact like when you have a package that is a native add-on, your entry point is typically still JavaScript. Like there's a JavaScript wrapper around the native code. Mm-hmm. And this JavaScript wrapper, it calls something like require with like a relative path, like build/addon.node. What does this require call do in this case? If the JavaScript file itself, if the index.js is part of the VFS.
The user would call CP in order to make it on the actual file system, then it would call require on the path from the actual file system.
I didn't really understand the part where you're talking about CP. So are you referring to copying the file contents from the VFS to the file system?
Yes.
Okay.
But the question is like, which files exactly do you copy?
That's what the user would decide, because basically it would be something that they would implement. They would decide which files are important to materialize on the disk, and then they would copy them themselves rather than have a built-in capability inside the archive formats.
Right. Let's say it's a library you're using, some NPM package that contains a native add-on. I believe Anna's concern is that usually those packages that include native add-ons try to load the native add-on from a path relative to the module's main script. So let's say you have your index.js file or something, then that typically tries to require or use the bindings package on NPM relative to the JavaScript file. Let's say that's in your dependencies and you copy the native add-on somewhere, but the JavaScript package that you're using will still try to find it relative to its own location.
So for my assumption, it was that in the case of native add-ons, since it's very difficult to find a way to make them work portably the way we would want without transformation, it would be acceptable to ask package authors to make changes in their code in order to be compatible with the VFS implementation. Isn't that the case? Do we want the VFS formats to support all existing packages without any change?
If your suggestion is to ask package authors of native add-ons on NPM to update their code, I think you are being incredibly optimistic. Like, it's not going to happen for a lot of add-ons that are just not actively being maintained, but still used.
One potential solution would, I'm not saying copying the native add-on anywhere is a good idea, but if we did implement some mechanism where when bundling an application, when creating a single executable, you could use a set of paths that are supposed to be extracted. And then in the VFS, you could have symbolic links to the actual files that have been extracted, so that resolving those paths relatively would still lead to the correct absolute path to the extracted files.
And I think that's what Azar does, right?
Yeah.
The table of contents of the Azar allows you to point to files even outside of the Azar bundle to solve that very specific problem, right? I think the only disadvantage of that approach, which I think it does sound like the at least the best that we can come up with in this call, it is what Anna said, which is that deciding what to unpack, then that becomes an interesting problem in some cases, right?
Yeah, and also, as mentioned earlier, a security issue. Once you leave unpacking things to users, you can have a signed binary and it unpacks data to an insecure location. It gets modified by an attacker and suddenly you have a security issue, especially with native add-ons that you can't really apply permission models to.
So just to break down the problem, by the way, so one I guess like fundamental question that I have, and I think this is mainly I think for Darshan, but when we say single executable application, how strict are we that the application must be a single binary? Is that something that we aim for from the Node community? I think Darshan, you have raised some things in the past about like really making it one binary, or is it fine, for example, to have one binary plus share libraries? Right? Is that acceptable, or to what level is it acceptable to the Node community? Like, how far do we have to push for a single binary, as the name implies?
Good question. So I think it's more like the way the single executables are supposed to be distributed. Like, these should be just one exe file, and we didn't really have any concerns raised regarding whether it would still remain as a single executable when it is run by the user. So I think just extracting parts of it on the file system is fine to an extent.
What do everybody else think on this call? Does that sound reasonable?
I mean, I can tell you, we did go out of our way to make it a real single executable binary in Boxnode, but I also understand that that works in a way that is not really compatible with what this project is aiming for. And in all fairness, it is fairly typical for executables to be shipped along with some shared libraries, especially on Windows.
It is, or it isn't difficult, you say?
It is common.
Okay, yeah.
To ship shared
Agreed.
libraries along with the main binary.
Yeah, because I think if we can lift off that constraint of really not worrying about having just a single executable, right? Then we can avoid a lot of additional complexity of, for example, some of the discussions that we were having, I think in one of the threads, about how to execute processes like within the BFS, right? And trying to like load it from there, or extracting that on the fly and see how that would play with like antivirus or something like that, and then loading shared libraries, for example, from within the BFS or not. it seems like a lot of complexity actually goes down, and we have like a quite some room, to play to at least attempt to solve this VFS native add-on thing. If we can say, for example, it's fine to have multiple files, and probably native add-ons would be distributed separately to the binary, right?
Yeah, and I think another point was raised by Mail, and it was about the installation phase. So I'm guessing that if single executables have an installation phase, it's fine if we don't treat it as a single executable throughout its entire lifetime. Let me see if I can find that. Yeah, this one.
Yeah, the thing is that unpacking everything, right? The whole thing. If you have, for example, if you have like a very big BFS, because the native add-ons is one thing, but if you have a BFS with like a lot of node modules, then you might be talking about like 100 files, that you have to unpack or more, right? And that, yeah, it's complicated.
And couldn't Node just when we're doing a require of a .node file, dynamically extract it on the disk?
Should
Transparently?
it be just .node files or some other file formats as well?
I mean, anything that would need to be separate on the
binaries.
disk to be loaded, right? I think that would be, for example, in macOS and Windows, like a Maco and portable executable files, like whatever that means, like a PTP, a DLL, an XA, a shared library, whatever, right? But I think, the main problem with extracting all of these on the fly is that it's very tricky, mainly on operating systems like Windows, right? Where like it's a lot more common to deploy like antivirus and Windows Defender and whatever, and then you can have like some random process acquiring like exclusive, locking on one of your IO operations and making that like take ages, and then every time you do that, you incur a very heavy performance overweight, or your files are going to be quarantined out of the box and then it fails. I think we have seen a lot of that in like the context of desktop apps.
Yeah, correct. I think Cheng Zhao from Electron, he raised a point regarding this. So that's in here. So yeah.
I think Darshan is our like search engine on the discussion, right? I think where everything is being mentioned everywhere. Just ask Darshan and he will open it up.
Yeah, this one.
Yeah, exactly. So that's what I'm saying, right? If we lift off the constraint of being able to leave some of these files on the file system on the side of the VFS or the bundle or whatever we have, then that seems to be at least what would get us closer. I think it's like the best approximation that I can see, at least, to a solution, right? And then maybe we can fix the problem of what needs to be unpacked and what not in some way.
Yes. And I guess the other question that might come up here is, in case we want to unpack these files, where do we unpack it on the file system?
But you don't unpack them on the fly. I think what Sheng is referring to is the functionality, the ASAR unpack feature, which means that at build time, when you're building your application, you create an ASAR that bundles what you want and points to references that are siblings to the ASAR at build time, right? So there is no runtime unpacking. This is like build time unpacking that he's referring to.
Okay, but then in that case, like ASARs are not technically single executables, because you would have the app.asar file as well as some of the other native resources on the file system. And that's probably something we don't want to do in single executables in Node. Probably...
Yeah, but that's the reason why I'm raising the fundamental question a bit before, right? Is that does this qualify as single executable or not? Because if it does, then this is a very interesting avenue that solves like a range of problems all at once.
I think this might be reasonable, especially since WebAssembly isn't concerned by this. We could still keep it inside the archive. So at least there would be a workaround to have pseudo native code inside a full single file application. And in the second iteration, we can try to see whether the current way the native applications work is satisfying or not. And if it isn't, then we can find another solution.
Also, by the way, to play the devil's advocate, I think given the name single executable application, right? I think what Sheng is describing, it is technically a single executable application because you have one single executable, but then you have a bunch of resources and shared libraries on the side. So technically there is still one executable, right?
Well, if you look at it that way, everything is a single executable app, right? Because Node is what you run, and that's the executable. And all the rest is
fair enough. That's a good point.
Yeah, like another point I can think of here is, do we expect users to decompress parts of the VFS? Like, should the code be in userland, or is that something we don't want to support?
What is a use case?
Like in case we don't really have a clear definition of what exactly we want to unpack on the file system, that's something we might have to leave to userland.
I think that the only tricky bit there, because I think we have discussed in the past whether the whole idea of BFS should be something completely in userland or not. And I think the main problem and like deal breaker, I think that we came up with at that point in time is that if you're implementing any sort of BFS, you need to make Node aware of how to redirect FS calls and require calls and all that kind of stuff to the BFS, which is what you have done, Darshan, with our custom build. So if we had any clear interface of how you like monkey patch all these calls, I mean, in case for other people, for context for other people in this code, so Electron what does is that it monkey patches all the FS functions and required calls to have, different definitions of whether you're using that to point to an ASR file or not, right? But they do all these with like very, very, very ugly monkey patching. But if you would have a very well-defined interface to support this monkey patching, then if that's in place, then the whole BFS thing can just move to userland just fine, right?
Yeah,
Right.
I think Mail raised a PR to do something like that. I think it's still in draft stage.
Sorry, which PR?
I think, okay, I'll probably have to find that out. But I think it's about implementing something like a VFS in userland.
So I made one, but it was, I think we put it aside because we are working on loaders. And the idea would be more to make it so that the loaders can override the FS module resolution and replace it by anything. So in our case, it would be by the VFS implementation that we have. So it wouldn't be directly inside Node, it would be provided by the loaders.
Okay, interesting. So would that require users to implement some of the FS functions?
Yes, exactly. And that's why I'm here actually, because I would really like if there was something in Node itself which allowed us to not have to re-implement the whole FS layer because it's very difficult to test it. Each time Node implements a new feature, we have to be made aware of them in order to add them inside our layer. And it's something we would prefer not to have to maintain.
And Electron actually has this exact same problem, and even PKG, right, from Vercel actually has the same problem, and all these projects do exactly the same thing. In the same ugly way, hitting the same problems, which is very interesting.
And I think in Azure, the supported feature set is actually very limited. In Yarn's case, we try to be more closer from all the features supported by Node, like by supporting file descriptor, by supporting watchers, this kind of thing. But it's a large surface, so yeah, as you said, it's a hard problem, and it would be really nice if there was something native that allowed us not to have to do that.
And the thing is that for all these FS functions, and again, like I haven't like dig like super deep into Node, so maybe like maybe Darshan and Anna know more about this. But I think require both the require function and a lot of these FS functions, right? Underneath, there is a very common layer, and I think that's probably libuv in the case of Node, that actually does the I/O. And if you can hook it in there, then could you have like how would you hook it with like the minimal surface impact that would work for the entire like FS module, right? Is that a thing?
I would love it if we could actually make the libuv functions that Node.js calls hookable. And I think that would be doable. It would just require being part of a project like this.
It would be
really nice
difficult to it would still be difficult to implement something and test it so that we can be sure that our layer is compatible with all JS applications that run on Node.
But I think it's an interesting avenue to follow because given all the discussions that we have on this project, I think both in this call and on all the tickets that we have open in the repo and even internal discussions that we had within Postman as well, it seems like the BFS is the part of the problem that is like the most tricky to really like knock down, right? And if we make that move, like strategically, if we make the move of making this whole thing like hookable on Node, then what we can do is that we can focus on the other aspects of for example, the SCAs, and then essentially like delay this for a while. And then hopefully by then we have like a lot more knowledge on the project, and we have at least something that we can use as a base of experiments for BFS that would fill in all the holes, right?
Yeah.
I'm not sure I understand what the MVP would look like if there was no virtual file system.
It's not that there wouldn't be any virtual file system, right? It's just that the virtual file system implementation is completely userland. So you can either, if you can package your entire application into a single JavaScript file, because for whatever reason that fits your use case, you can just do that and avoid the BFS. Or if you need something else, you can actually integrate any BFS that you want, right? So that would push a little bit more work, for users, but it would like delay the problem of us trying to figure out what's the best BFS ever, right? Until we see actually some things coming up in practice and maybe, bring back the learnings.
I think that's something that should be fairly simple to implement with our ZipFS. However, the performance would not be great, and in order to include binary payload like an archive inside a JS file to make it one single file, we would have to encode it into binary base64, and it would also take a lot of space. So it wouldn't be as good as it could be if it was native, of course.
In what way? I don't think I get it.
Sorry?
So you mean native? You mean native? I guess your definition of native means bringing ZipFS support to Node itself in a native way for performance rather than doing ZipFS in JavaScript.
Yeah, exactly. Because from what I understand, what we're suggesting is that as MVP, we implement a way to bundle an application so that we have one JavaScript file containing the ZipFS, the VFS implementation and the VFS archive that the VFS implementation will then inject into Node by hooking into the file system, right?
Okay, interesting.
Yeah, I think that would be cool.
Like, how would we run the code that's supposed to make sense out of the VFS that has been embedded? I'm guessing it's supposed to be something like a bootstrap script, because we wanted to be able to load stuff right when the app starts, but I'm not really sure where to put that in.
That can be the same script. So in the same script, you have basically three parts. You have the binary of the archive itself, which is stored as base64 in a variable. You have the VFS implementation, which can read from this binary string and access files transparently from them. And finally, you have the Bootstrap code, which will inject the VFS readers into the Node primitives, into FS, for instance, and then call it. That's kind of what Yarn is doing with Yarn PNP, where we take the zipfs implementation and then we hook it into Node so that it is able to read the files from zip transparently.
Okay, interesting. But if we do that, I'm guessing the code that's supposed to contain the VFS implementation, it would also be another file that would get embedded into the binary. So how do we expect the app code to fetch that part of the code and run it? I'm guessing.
Yeah, that's a good point, actually. So it's a bit of a chicken and egg problem at that point, right?
Yeah.
I don't understand. Sorry.
I'm talking about the VFS implementation, that JavaScript file, which is supposed to make sense out of the embedded VFS. It would probably have to be embedded into the binary also. And I'm guessing there's no way in which we can fetch that part of the code unless you have a VFS for that.
It would have to be implemented in JavaScript, and it would have to be in the right before the bootloader part. So it would not be part of the archive itself.
Okay. I guess the way I was thinking about doing this for the Leaf implementation I was working on earlier is that you'll probably have two segments. One of them has the VFS that we want, and the other one would have the code to make sense out of that VFS. And we would package both things into the binary, and the app code is supposed to. Yeah, but unfortunately, this just crashes when we use Leaf to do that for some reason. And I'm not really sure.
Okay, but that sounds like a solvable problem. But I think that's an interesting take, and I think it's essentially what Mail is also pushing for, right? So if we manage, so assuming that we have that we make that Leaf bug go away, right? And you essentially encode two segments, and one of them is like the Bootstrap, right? Which given that what we're talking about like delaying the VFS problem as much as we can, right? Until we know better what to do, then it means that people can inject in there whatever they want. Right, like any JavaScript file that would hook into like zipfs, ASAR, or any custom VFS that people can think about, right? And then at some point, if we figure out a solution that truly works based on what we have learned and that covers all the cases, then we can ship that segment internally out of the box, right? Pretty much.
Yeah, that makes sense.
Yeah. I think that sounds sensible to me, and I think if we follow that route, at least we can start working on some of the things with Project and the Bootstrapper, as we're talking about, and not get caught up for months on the BFS, because it seems to be a super tricky problem, right? That sounds like a good way to just unblock a lot of progress on the project, and then revisit at some point. I mean, I just keep an eye on that and see what people come up with. For example, I think if we ship something like this, I think Mail could make use of this interface to implement, support for zipfs and all the stuff that he's doing on Yarn, right? And we can experiment with doing the same with other archive formats, and even, for example, having one example Bootstrap script using ASARs as well, right? And then see them, in comparison for real, which might be very powerful.
Yeah, that seems reasonable.
And considering the case where there might be multiple VFSs that might just support everything that we actually need, it might be a good thing to just offload the task to userland.
Right, but the thing is that it's a bit like cheating, right? Because we're saying, we don't know the solution. We hope that you know the solution. And the fun thing is that if we don't know the solution, I think like random users of SCAs will actually know even less, right? So it's kind of a cheat that they were like pushing that to them. But I think it's also for like the sake of experiment, is because we can then observe what they do and the challenges that they face, and then maybe that helps us figuring out what the best solution is, right?
Also, I don't think we can just keep the VFS forever outside of Node itself. At some point, we will have to make a call about what format is the best and implement it natively so that we can have much better perf that we would be able to remain in user land. So this is just an intermediary step.
For learning purposes, essentially,
exactly.
for research purposes.
I guess we're over time by 7 minutes, so I guess we could call it the day now, given that we have some conclusions on some of the topics.
Yeah, thanks a lot. And so just before we end the call, so just for the sake of documenting some of the things that we talked about, I would like to drop some notes about this call. What would be the best way though? Darshan, should I create a PR with the notes? I could have discussion.
Yes, exactly. I'll let you know async. I could probably open a PR too, adding some meeting notes.
Okay. Exactly. And then we can document at least a decision that we came up with on this call.
Yeah, absolutely.
Nice.
Have a good day, Ben.
Awesome.
Okay.
Yeah, same. Thanks a lot for joining us,
mate. Question actually. So should we have more calls? Like, should it be weekly or should it be on a need basis? I guess this is something we could probably discuss async too by opening a discussion.
Yeah, I think it would be best because then people who couldn't join this meeting will be able to.
Yeah, let's do that then.
And let's do email invites, by the way, Darshan, because I actually didn't realize that the SCA call was happening now, unless until I saw your message by accident, right? So I think there should be a nice way to create a calendar invite that people can subscribe to or something like that.